Hi everybody, welcome back to the Lantern presentation videos. For this one, we're going to be talking about a holding pattern, specifically for time on target situations. So first things first that we want to think about is where the target is. So for this instance, we will just have our target here, unspecified, exact area and whatnot. Following this, what we're going to do is we're going to kind of think of what speeds we're going to be operating at. Now, the easiest thing to do here is just think about indicated airspeed. So, in knots. The downside of this is you can't get proper miles per minute from that. So, what we really have to do is think about what ground speed we're going to be flying, like in our holding pattern, as well as going to the target. So, if we're thinking about 300 knots, in a normal situation, that's roughly around 420 ground speed. So we'll just put that up in the corner here. That way we know what we're referencing. And from there, we can kind of get a rough idea of how we want to go ahead and conduct our situation here. So first things first that we can do here is we can just put in an easy number of 4.5 to 5.5 miles. So before I actually say what that is, we're just going to kind of build like a timeline. So in the end, we're really going to be out here, like where our aircraft is at. But right here, we're going to just ride around 5 miles. So maybe asking yourself what that 5 miles means. So that 5 miles right there is quite literally where our release point is. So right here, where this is going to be, this is roughly where our release point is going to be. I'm just going to roughly draw an aircraft. Okay. So that's where our release point's going to be. That's where the bomb's coming off the jet and all that sort of thing. In reality, we should be thinking about time and not distances. But for this case, we can do a little bit of both. So if we are thinking that our bomb is going to take 40 seconds to hit the target, we can also write that. We can also put a little like time graph here, or a timeline per se, and that's going to be 40 seconds. Then we'll just do that. So that's 40 seconds. So now we need to think about, okay, now we're thinking about time on target. So we need the bomb to hit the target at 0600, right? So from here, we need to realize, like, okay, what's 40 seconds behind of 0600? So that's now 0559 and 20 seconds. So, okay. So now how do we get to this release point in time? Like, how do we look at our lantern? We check the time. We want the time in the bottom left of the lantern to say this. We want it to say 0559 plus 20. That's when our time to release on the actual lantern says 0. So one thing that we can do is we can think about, okay, I want to be a minute away from this. So this is where starting to think about time is very, very helpful. If we are wanting to be a minute away from that, well, that's fairly easy. We just, we put this out this way, and we put down, well, a minute, that's going to be 60 seconds. So now we are going to be a minute away. So now that we're thinking about this minute away, now you're saying, what does this mean? Well, now this right here is our IP. This right here is now going to be our IP. This is where we are going to be pushing from, and in reality, this right here is our push time. We're going to be pushing from here to our release point and not actually pushing from the IP to here. The big misconception of this entire thing with TOT is that the distance between the target right here and this right here has got to be a round number, because in reality, it probably won't. So we're going to just push this out right here. So that's 5 nautical miles, right? We're roughly going to be 4.5 to 5.5 miles on our release, depending on altitude and all that sort of thing. If we are thinking about 420 ground speed, well, we know that, 420 divided by 60, that's 7. So that's 7 miles a minute. So this right here is 7 miles now. So now we're thinking, okay, now I know exactly where my timeline needs to be on how I need to get to the target. And now we start to think about actually, where the target is at in relation to our holding pattern. So kind of thinking about it in a top-down view now. Now we're thinking about racetrack patterns. So I'm just going to continue on my drawing here. This is our timeline here, all that sort of thing. So there's our 5 miles. And this right here, this will be almost in a sense, this will be our commence point. This is just like the Case 3 Marshall, all that sort of thing. So this will be at 13 miles from the target. And like I said, this won't be a perfect number all the time. This might be something like 13.5 or something along that. And that is really going to depend about this number right there. So now we start to think about the holding pattern. So the easiest thing we can do is just purely think about it in the Case 3 pattern. So we have 1.5 minute turns, as well as a designated length of the leg, as well as coming back, 1.5 minute and all that sort of thing. The easiest thing we can do in the Tomcat is go 250 knots, right? In a 30-degree bank, we know that is a 1.5 minute turn because, that's how we do the Case 3 Marshall. So now we really have to factor in speeding up to the target, which is a completely different story, which in reality, you can't really pre-plan for that much. When you have to speed up for the target, like your lantern is going to be reading, it'll be reading like 40 time to release or whatnot on the lantern, and you have 30 seconds till this. So like in reality, actually, I'll just give you an example. You're pushing towards the target, and you're 10 seconds behind. So your lantern is actually reading 05:58 and what would that be? 50 seconds. So that's literally what the lantern is going to read right there. That's what the bottom left of the lantern is going to be reading. So now you're thinking, oh shit, I'm screwed. So now you actually have to speed up at some point, and now because you're speeding up, because you're flying faster, your bomb is going to take longer flight time. So now you have to speed up even more to compensate for that. So in reality, we want to be faster than slower because it's easier to slow down than it is to speed up, right? It's easier to be ahead of schedule than it is to be behind, right? So that's really all that goes. It's really on the holding pattern itself is going to be being very, very smart about your about how much time you have. So getting to the AO usually, let's say we'll have 10 to 20 minutes. You have 10 to 20 minutes till your push time here that you can figure out this entire pattern here. And that's perfect. You can roll up with your dash 2 in reality, your dash 2 might have a completely separate time or whatnot, but for this case, let's just assume dash 2 has the same numbers as you. You can set up your orbit here. You want to show up at this point right here. If everything goes right, you can literally just do 2 or maybe a single 360 and head straight towards the target. So, a full circle there and then heading straight towards the target, that's a whole 3-minute circle. So you really want to show up 3 minutes right on the dot. You want it to be divisible by, 3. So, 3, 6, 9. You want to show up at your commence point at that exact time. So when in reality, if you really want to get good at this, when you're coming towards the target, so like you're actually en route from the carrier or wherever you're taking off from, try and hit this as a push time. Hit it as its own separate push time. So coming in, you're looking at your TID and whatnot. You have this as an actual waypoint in the jet. You have this, you hit 5 on the cap as the Rio, and now you are reading the time to go. Try and get this at a divisible 3 number, right? You want that to be, 3 minutes ahead of this. You want to be, 6 minutes ahead of this. All that sort of thing. So, you want to be hitting this roughly around, if we're thinking about 3 minutes, we want to be showing up at 05:55 in 20 seconds. Now, you don't have to be super precise about the 20 seconds if you're showing up just initially, right? The 20 seconds starts to only matter when you start to get closer and closer to your actual push time, as well as actually going towards your release point. And that's just the major thing, right? Is you do not want to be behind. Like I said, you want to set up yourself that your pilot and yourself as the Rio, or vice versa. You can just sit here in your orbit and you do not have to worry about being behind schedule, being ahead of schedule. Set up fake push times in your head as the aircrew so that you can show up on time when it matters. And it's really, really going to be, like I've been saying, it's relatable to the K3 Marshall, right? The big downside is we don't really have a course arrow here. So when in your planning phase, you really want to be, hey, we're going to be 13 miles as our IP, and we want this heading right here to be, 180. We want to head straight south towards the target. Because as soon as you're turning around in an unconventional way, because you're a little late on your time, now your heading is going to be somewhere off here. And now you're reading 1-6 something. And now you have your Rio bitching at you that you're 20 to 30 degrees off of where the lantern's supposed to be looking. And now, because you're 30 degrees off, you're no longer going straight towards the target. And now all it's compiling together, and now you miss your time on target. With just this rough method that I've put all here, you can hit your time on target on the dot. You can hit this within a second. And in the next slide following this, I'll actually just show you an example of me using this exact method.